Hi there guys, got a little video here for you today on the Benjamin Akela, and what we're going to be doing is fitting a spring stop guide to it. So an SSG or spring stop guide is just a device that captures the hammer spring, and the main aim of it is to increase the efficiency of the rifle. I'll explain a little bit on how it works when we actually get down to fitting it. For now though, I have got a prototype in the block already that I've been testing, and so far the results have been quite good. From the prototype version we're getting around 20 extra shots at the same regulator pressure and the same pellet speed. But apart from the SSG, the Akela looks a little different from the last time you saw it. We've refinished the stock. It's been true oiled. My dad did the refinishing, so I didn't get any footage of that, but I'm really quite happy with the way it's came out. It does look a little shiny on the camera, but it's much more of a soft sheen in real life. But it has brought the walnut out nicely. It's a nice grain on this stock. But there it is there. Really quite happy with the way it came out. The other thing I've made is just a plastic cover for this piece of pick rail here. The standard cheek piece is way too high, so just made a new one that slides over the pick rail. Just allows you to get your cheek a bit lower. Not the most comfortable thing in the world if I'm honest, but it's better than resting your face on raw aluminium pick rail. The other thing we've done is just put a barrel band on the end. I haven't really noticed a massive increase in accuracy with the barrel band, but what I have noticed is that the point of impact shifts a lot less now. The Akela wasn't super bad for point of impact shift, but because I shoot off a bag, when you reload the magazine you tend to sort of drop the rifle on its side, and the bag was actually touching the barrel. So the first couple shots, or first shot after you just picked it up, the point of impact was normally shifted a little. It did return back to normal, but the barrel band just keeps that nicely in place. But that's about it. The Akela's still running really quite nice, as it should, and I'm really quite happy with how this little rifle's turned out. Right then, so let's get started. So I do have a full disassembly of the Akela on the channel already, so if you want a full disassembly with all the anti-tamper removals, you'll just have to search on the channel, or I'll put it in the corner. But we're taking the stock off with a 5mm Allen key, just in this hole in here. Remove the stock, we'll stick that to one side. Next we're going to remove this little trigger plate on the side here, and that's using a 2mm Allen key. And we'll lift this plate up. Next we can unhook this little trigger linkage at the back here, like so, and then using a 2.5mm Allen key in these two screws here we'll take the air cylinder off. Don't need to take them all the way out, they're just dimple grub screws, and then we can pull the cylinder out. There it comes there. Now we're left with the block. Next we need to take the cocking linkage off to get to the cocking dog. To do that we need to take this top piece off, a 2mm Allen key. Then once them screws are loose we can just pull the top piece off and remove the cocking arm. There it comes there. Next, using a flat bladed screwdriver we can take the cocking dog out. Then on the underneath we take the locking screw out for the hammer spring. We don't need to take this all the way out, just loosen it a little, then we can push this pin out. With everything loose and the pin out we should just be able to tip the hammer spring. So this is the SSG that I made. Show you a little more on that in a second. Then we can tip the hammer out. Right then, so this is how the SSG is assembled in the rifle. This part here is our SSG, our hammer. This part here is just simply a spacer, so that normally the spring acts on the base of the hammer right in there, whereas with the SSG we need a standoff so that this rod here, this one there, can easily travel up the centre of the hammer, and we do that with just this hollow standoff. So it goes in the back there and allows that rod to travel up the centre of the hammer. So the main aim of the SSG is to improve efficiency, and it does that by eliminating or reducing hammer bounce. So very simply, hammer bounce is when the hammer strikes the valve then opens, putting the puff of air out the barrel and pushing the pellet out the end. Then when the valve closes, it forces the hammer back against the hammer spring, and because the hammer is given a bit of energy, it compresses the hammer spring and then fires into the valve again. Now this isn't a full strike, it's a partial strike, but in some cases it's enough to reopen the valve and waste a little bit of air. Hammer bounce is particularly prevalent on rifles with preload. So in a preloaded configuration, the hammer would be pressed up against the firing valve using the hammer spring. The SSG allows the hammer spring to be back here a little so that the hammer is free to float within the rifle so that there's no hammer bounce. Or if there still is hammer bounce, it's greatly reduced. In some cases it can't eliminate it completely, but it definitely does help it. Right then, so this is our prototype SSG. Uses some of the original components with just a threaded rod in the middle there, with a nylock nut on one end, a couple of Delrin top hats, and under here, and under that is just the standard Benjamin Akela hammer spring adjuster. So we're going to be remaking this as one unit. At the moment, because everything is a bit loose and a bit floppy, there's an awful lot of twang from the spring as we fire the rifle, so remaking it as one piece should eliminate some of that. We're also going to try and insulate a few more things. I plan on making a little Delrin sleeve that goes over the outside, just to stop it resonating within the block. The other minor changes we've made is that this is no longer the standard hammer spring. We've swapped it out. This one is the standard BSA R10 sub 12 hammer spring, and it fits in there quite nicely. We're still able to get the power we want, but it's a slightly softer spring. We've only gone for a slightly softer spring to reduce the cocking effort a little. If we were to go for a shorter, stiffer spring, we probably could get a little more efficiency, but with this spring installed we're experiencing about 20 to 25 more shots. But again, that could be greater with a shorter, stiffer spring. The other change we've made is to shorten the stroke a little and add a peak tip to the end of the hammer. So that's a 2mm extension on the end of the hammer there. Right then, so onto the making. We've got a piece of steel chucked up in a 3-jaw, and we're just turning down one end, and this will be the rod end. We'll thread one end M4, and then the 2 Delrin top hats will just slide over this rod. I won't show you all of the turning down, it's quite boring, so just a couple passes, then we'll move on to the next. So the length of this rod is quite important. If it's too long, the hammer will bottom out on it, and if it's too short, we won't get the adjustment we need for the hammer spring. So we're going to be making it a couple mil over length, fitting it to the rifle and turning it down to the perfect length. Ideally, we want it just shy of the bottom of the hammer. This will give us the maximum amount of adjustment. But once it's turned down, we can chamfer the end, then thread it. I'm only using a die to thread it. Single point threading a rod of this diameter, and this much stick out would be quite difficult. You could do it using a follower steady rest, but that's a bit too much work for this operation, so we're just going to be using a die. And then we're just using the Jacob's chuck to keep the die nice and straight. But once the die is started, we can take away the tailstock and just do the rest by hand. We don't need a really long thread, just enough for a little bit of adjustment. And then lastly, in the lathe, we're pressing over the little Delrin sleeve. That's going to be going at the back. I made the Delrin sleeve off camera, but it's a very simple job, so you can imagine how I did it. So we're pressing it over, and then we're turning it down to just over 16mm to make it a nice fit in the block. It's not too tight, but there is a bit of resistance as it goes in. This is exactly the fit we want. The idea of the Delrin sleeve is just to add a little bit of insulation between the block and the spring. Once all that's done, we can move it over to the mill and mill the slot in it. This slot's for a little retaining pin that we pushed out earlier. I'm making my one a little tighter than the factory, but I want it to still go in easily, as from the underneath there is a set screw that presses the hammer spring assembly against this pin. So there's little point in making the pin a super tight fit. But once we've got the slot done, we can flip it over using the 4-sided collet block. Using an end mill, we'll create a flat bottom, then coming back with a stub drill, we can drill the little centre mark. And that will act as a little bit of positioning alignment for the grub screw. After that, we just chopped it off in the span saw, a little over length, and then we're turning the face down so it's just a little shy from the back of the block. Again, using the original as a pattern. Last thing we've got to do is make a couple of top hats. These will run on the rod shaft that we turned down earlier and carry the spring. And what I've done is made the internal top hat length so that when the spring is totally bottomed out, these 2 top hats touch. And doing that just makes sure we can use all of the spring. Right then, that's pretty much how we made our SSG. What I'll do is I'll link a very interesting article on SSGs in the description. Obviously we didn't come up with the idea for an SSG. It's one that's been floating around for a number of years now, and this is the first time we've tried one, but it's been a very interesting little experiment. So we mentioned earlier that the main aim of the SSG was to improve efficiency, and the main way it done that is by removing any preload that would be present on the valve. Now there is a secondary way in which the SSG improves efficiency as well, and that is because the spring is pre-tensioned, it acts as a buffer. So when the hammer rebounds with the closing force of the valve, so the hammer hits the valve closes and pushes the hammer back towards the hammer spring. Because the spring's already pre-tensioned, it takes more force to compress the spring, and therefore the spring acts more like a buffer than allowing the hammer to bounce back and forward between the valve and the hammer spring. That's why in this rifle we didn't have any preload to begin with, but we're still experiencing a greater shot count. Right then, and here's the SSG all made up. We've put it together, put the two top hats on. I'll probably only show the making of one top hat, but we have one at either end. We have our hammer spacer here, so this pops in the back. We've also got this spacer here, which acts as an external spring guide, just to take some of the ring out of the spring. Right then, so to adjust the power, it's a little unconventional. What we have to do is actually change the length of these pieces here. So we've got this spacer here, which goes in the back of the hammer, and lengthening this is essentially the same as increasing the hammer spring tension in a traditional adjuster system. Same goes for the thickness of these two top hats here. Slightly different with these ones, as these also increase the passive spring tension, and then this nut on the top dictates the length of travel for the spring. So we do have a small amount of up and down adjustment on the power. We can undo this nut slightly and the power will rise, and if we do the nut in, it will drop slightly. It's not a lot of adjustment, but we do have it there. So if I'm honest, it's not the easiest hammer spring to adjust, but the reason we did it like this instead of one with a adjuster on the back here is that I wanted it all to be one piece. The original design was sort of two pieces that screwed together, and there was always quite a bit of movement and flop in everything, and it didn't really work that well. This version, all being one piece, or one solid piece with the spring attached, should be a much more solid design. You could do it a number of other ways. If we didn't want to use the longer and softer spring, what we could have done is actually put the spring on the back of the hammer itself. So make a top hat that the spring presses up, so the spring would be right out here, and the rod could be a lot thicker and go down the middle of the hammer. We tried that design, but because we wanted to use this spring to reduce the cocking effort, we needed the actual spring length to be a bit longer, so we needed to use this design here. So that goes in the back, and that allows us to use a longer and softer spring. Right then, so let's put all this in the rifle, then I'll tell you about the shot string. So first thing we're going to do is take our hammer and drop it in the back of the gun. So this way up. You may need to pull the trigger sear up to get the hammer in. Once you push it past the sear, it should go in nice and easily. Then we'll put the cocking dog in. Just drop that into place. Then using a flat bladed screwdriver, we'll just do that up. Get that nice and tight, you don't want that coming loose. Next we'll put the bolt on. Just drop that over like so. Make sure the cocking dog is actually in front of the hammer. So there that is. I'll drop my spring guide in the back. Then I'll take my SSG and also just put that in the back. Press the little pin in. If the hammer won't go forward, you can just decock the rifle nice and carefully and then push the hammer spring adjuster in. Once that's in, we can do this lock screw up, this with a 2.5mm Allen key. Stick our trigger plate on and do these screws up with a 2mm Allen key. Then we can drop our Picatinny rail on. Doing that up with a 2mm Allen key. Then finally I'm just going to slide the cheek piece over, and there the rifle is. The last thing we're going to do is just put it back into stock. line the stock up nicely, put our bolt in, and then do that up with a 5mm Allen key. And there we have it, Benjamin Akela with an SSG. So I'll just try and get you a listen to how the SSG sounds in the back of the rifle. So I don't know how well the camera's going to hear that, but it's a nice crisp pop to it. It doesn't sound like the hammer's bouncing off the valve. So before fitting the SSG to this rifle, we was getting about 240 shots from a full fill. That's obviously with the regulator that we installed. And then with our prototype SSG, that bumped up to around 260. The new SSG that we've just made bumps that shot count up again. We're now getting around 270 shots. So a 30 shot increase over the standard rifle with the reg in it, and a ton more shots than we were actually first getting out of the rifle. When we first got this rifle, before we put the reg in it, we was getting around 50 or 60 shots out of it, and that was being generous. So going from 50 or 60 to 270, a massive increase. I'm really quite happy with that. So apart from the increased shot count, we haven't really noticed any other changes with the rifle after fitting the SSG. It's no more or less accurate. The feet per second spread may be a slight bit better, but it's hard to tell. We'd have to do a few shot strings and average them out. Before fitting the SSG, we were getting around a 15 feet per second extreme spread over the entire fill. You would get one or two outliers in that, but the average extreme spread would be about 15. With the SSG, it was a little lower, but that could be just because the reg's bedding in, or the rifle's in a better position, tune-wise. The only negative I'd say to fitting the SSG is the slight twang that you get in the ear. It's not enough to be off-putting, but you definitely do notice it as you're shooting. Although having said that, if we were to fit a stiffer spring, that may cure that problem. But at the moment I'm quite liking the very light cocking effort. Right then, that's going to about do it for this one, guys. I think we're pretty much finished with the Benjamin Akela now. I'm really happy with how accurate it is. We're getting a phenomenal shot count out of a fairly small cylinder. And overall the rifle's really performing well. I'd say the Akela is definitely one of those guns that's on the budget end, but with a bit of love and attention you can really turn it into a nice gun. Even something simple like fitting the reg absolutely transformed the way this rifle shot. Right then, so that's it for this one, guys. Thanks for watching, and I'll see you in the next one.